so before we get started with this first example of an angle of the elevation, I have a little surprise for you guys. I brought Charles with me, my precious baby, and you can see my husband in the background who's been working. It's Labor Day, and we're working hard just for you. Aren't we, Charles? Aren't we, Charles? He's so sweet. See, he doesn't even care. He's a movie star. Alright, so anyways, angle of elevation. Lay down, baby. Lay down. Yeah, he's been in my lap this whole time. We are going to draw a picture. We're going to do some art in here. So we are going to draw a building that is 21 meters tall. So let's draw just a little, I don't know, I want to do this nicely. So here's the ground. And then here's my building. And it's 21 meters tall. So I'm going to write that over here. And realize that this side's 21 meters tall, so is this side. And it casts a shadow that's 25 meters long. So let's say that the shadow goes to like here. And that's 25 meters long. So let's find the angle of elevation. Remember, that's from a horizontal line up to an object above. So find the angle of elevation from the ground to the sun to the nearest whole degree. So we're going to draw our sun over here. And you can see that's what's causing this shadow to occur. And this is forming a triangle. It's saying what's the angle of elevation to the sun. So that's going to be this angle right here. Notice horizontal line, angle, or ray to an object above. So theta is what we're looking for, and we just learned in the last example how to solve a triangle. It looks like we have a triangle with the two legs. We're given the opposite side and the adjacent side. So here, our equation is going to be tangent of theta equals 21 over 25. And then from there, we just simply solve it. Now, keep in mind if we need to find theta, that we have to get rid of tangent. And the only way to get rid of tangent is by using the inverse, the inverse function. So we're going to do inverse tangent of tangent theta equals inverse tangent of 21 over 25. These tangents cancel each other out, and now we can approximate our theta. I'm going to grab my handy dandy calculator and hit second tangent, and then 21 divided by 25. Can't see any of that. There you go. Close my parentheses, hit enter. I get approximately 40.03. Anytime we're in degrees, we're going to round that to the nearest whole degree. So approximately 40 degrees is the angle of elevation. That wasn't too bad. Now let's try an angle of depression. This one looks a little bit longer. So sighting from the top of a building. So we're going to need some ground again and a building. Here's my ground, perfectly flat. And here's my building. On top of the building, a 6-foot tall surveyor. Oh, so there's a little dude up here, and he's 6 feet tall. And he's like looking through a telescope looking thing on a little tripod. There you go. Alright, so a 6-foot tall surveyor measured the angle of depression to a tree on the ground to be 68 degrees. Alright, so he's measuring an angle of depression to a tree on the ground. So here's my tree. And he's measuring this. The height of the building is 112 feet. How far away is the base of the tree from the base of the building? So we're looking for this distance. We have how tall the building is, and we are going to write in the angle of depression. So it says the angle of depression to the tree on the ground. I'm assuming it's going to be like this. So the base of the tree on the ground is probably what it should have said. And that's 68 degrees. So there's a little tricky part here because this dude's 6 foot tall. So that means his little surveyor thinks 6 foot tall too. So this side of the triangle is actually the height of the building plus the height of the man. So that's 118 feet. Tricky. So now we just determine our missing side. Well, we've got an angle here, theta, 68 degrees. We've got the angle that's opposite from it, or the side length that's opposite from it, as well as the side length adjacent. So opposite, adjacent, that sounds like tangent. Again, so we're going to do tangent of 68 degrees equals our unknown angle x over, our unknown side length x over our adjacent side 112. And now we're just going to solve this equation. So to solve it, multiply by 112 on both sides. 112s cancel, and we get 112 times tangent of 68 degrees equals x. So now I'm going to type that in my calculator and approximate the length. Make sure your calculator is in degrees, and it looks like 277.209. So that's 277.21. X is approximately 277.21 feet. That's how far away the base of the tree is. So as you can see, the most challenging part about these is the word problem portion. You have to draw the diagram appropriately to match the word problem. This skill was basically tested in the last lesson, so we should be good on that. But we do need to learn how to read a word problem and translate it into an equation. So go ahead and glue that in, and on the right hand side we're going to write a problem. I'm actually going to write it and then pop it up in another video.